So I apologize up front for the bad lip dub here. Apparently the sound did not go through. Given the fact that some of these units I've had to record 3 times, I'm just past it, to be perfectly honest. So I apologize for any dead air. We're going to go through section 3.2. Can you guess my IQ? We're going to start introducing how we can get standard error and what R squared is when we have 2 variable data. So we'll see. Yeah, I don't know what that face was for. But so the problem here is students have counselors that update the transcripts for them. Adam, Bernard, Christy, Deja, and Eldon, wonderfully alphabetical order. And they've got IQ scores, but they got all mixed up. Now, why IQ scores are on a transcript, I don't know. But anyway, hence is the problem. So we have a new guy counselor, and so he decides to just average the IQ and put them. Fair enough, maybe. So when you average it all together, you get 103 IQ points for each of our 5 students. Adam, Bernard, Christy, Deja, and Eldon. So now, I mean, it's not it's a fairly common way to try to do things, but this counselor, who is the veteran, finds a formula on the back of the AP Stats room that you can convert GPA to IQs. So she goes through and finds the GPA of each of these 5 students and then plugs them into the equation. So when you do that, these are the scores that you get. 86.1, 95.7, 103.7, 111.7, and 118.1. Now, obviously, the benefit here there is that it does kind of spread out how the data works a little bit better. Now, it's not the exact same as what the IQs are up on top. And it doesn't necessarily guarantee just because you have a higher GPA that you have a higher IQ, but who knows? And Counselor 3 decided to, hey, let's just talk with people. So he talks with each of the students and gets their actual IQ scores out of this. How many of you know your actual IQ? I don't know. And those ones that you do on the web probably aren't accurate to the point of actually doing against an actual IQ test, but hey, we've got our 3 different ways of doing it. So we're going to go to the second page. Nice transition, Mr. Hayes. So we're going to go through and we're going to actually see how far off each of the predictions are. So we're going to start with the new guy predictions, and then we're going to go back and do... I don't know why I did that. That's all right. So anyway, so the predicted IQs for the first one is 103. So we're going to say how far off, and you may have done this in science class before, where you kind of go say, here's my model, this is what I should have gotten, this is what I did get, or did observe. So we're going to find what the error is. We're going to subtract those off. Actual minus predicted. So I get negative 18, and then I'm going to square them. Why? Similar reason why we did for standard deviation back in the earlier chapters. And again, please make sure that you type it in as parentheses negative 18, parentheses squared. When you square numbers, you should always get a positive number, unless, of course, it is imaginary. And there's an imaginary component to it. So 102 minus 103 is 2. Let me catch up on the math here, 4. And then I get 17 after I do 120 minus 103, and square that, I get 289. So we're going to sum all of those up. So when I do that, we get 730. That's, who knows? We'll have to see. Seems like a lot. So we're going through the veteran counselor. Here's the predicted IQs again that we're comparing to the actual. And as thought, these tend to be a little bit more, at least, I mean, they're in the order, but Deja over there has a higher GPA than they do IQ, so we will see. But like this one, much closer. Here I get a difference of negative 1.1. So that's much better than the 18. This one we get a difference of 0.07, negative 0.07. So we're going to square that. And that's, again, I mean, we've already just saved, 380 some points there. This one's fairly close to what we had before. feel like I'm dubbing a movie, to be honest. And then we do that. Finish out the math. We add all those up and see which one's better. Guess who's going to win? So it's actually 89.89. Much closer than 730 in terms of squared errors sums. So, who did better? So the veteran did better. For sum of squares, sum of squared errors was less than the sum for the new person. And you probably, I think I put the number in here, right? Yeah. Not that you can read it because apparently I'm not watching my screen. Hey, there we go. Good job, Mr. Hayes. I always start off trying to print, and then it blurs into this writing. So it was less than the sum for the new guy. And down below, okay, so there's the sum. So the bigger question is how much more of an improvement possibly do we have? So we're going to go through and we're going to calculate out the percentage of improvement. Now this may look really familiar with some of your science classes, depending upon how or what classes you took and how your science class is run. So we're going to go ahead and take the further out score minus the better score, so that we can see how far off they are. And when we do that, we get an answer of, oh my God, 0.877. Now, the other way that we could do it, so we improved by 87%, roughly 88%. Now, we could also go through and see what the typical error would be per student. And so for that, what we can do is we can take we're going to take the veterans teachers here. And so we're going to take it off. And now remember, like when we did standard deviation, initially we divided it through by the 5 different students. So when we get that, we get a standard error, a potential average error of 4.24. Now, if you enter this data into your calculator, okay, we're going to find the correlation and the coefficient of determination and talk about what those are here in a second. When you plug it all into your calculator, and we'll talk more about that in the next video, actually, if I'm remembering correctly. I look a little lost here. I think I'm trying to pull up the calculator, to be honest. Wow, these are things you can just cut out, actually. Hey, there we go. Good job, Hayes. So, typing in the data. I believe I said something. This is like, obviously, very, very exciting. I think I learned not to use the keypad on this one because I changed all my transitions to the keypad, but that's a whole different story. Maybe I can show you guys my setup for my 250 subscriber special. Comment down below. Trust me, in future videos, I decided that I needed to have all this preloaded, so sorry. This is time you just don't get back. So now, if we run it, so we're going to go again to stats. We just edited everything, so we're going to run the calculation. 2 variable stats, and it's the wrong one, Hayes. What were you thinking? Look at the slight panic in my eyes there. So we're going to quit back out. Nope, go back. There you go. Good. Calc. Running your linear regression. part that you're forgetting is that there's a way you can get it into the diagnostics. I can't remember if I set that up today or tomorrow. So my apologies. I think for sake of time and embarrassment, I just said here, trust me. Or you can go actually, oh, I actually did on this one. Okay, so you're going to go down to second catalog, and you can get a list of all the different commands that you can do on a TI-84 or 83. And if you press the letter down on the keyboards or in the keypad area, then you can jump to that letter. So you're going to turn on diagnostics on. And when you do that, it's not everybody needs it. When you run a regression, you can actually get these values back out. Maybe I should have re-recorded this. This was not necessarily my best day. My apologies. Actually, this is the second time I recorded this video, so now this is actually the third. So anyway, so R squared is going to be 8.877. Hey, that looks familiar. 0.936. The question is, why is the standard error goofed up there? I think I cut back, but we're going to talk about that here in a second. So I'm just copying stuff over, and apparently I forgot to flip the screen over to the camera. What I'm saying is if you look at the 0.877 for R squared, it's the same thing as the percentage improvement up on top. And that kind of will tell us how much of the variation that we're seeing is taken into account by our linear regression line. And now I'm probably writing down S. Come on, Hayes. I have my video output on a different monitor here. There you go. So 0.877, those are going to be the same. The reason, so then the next question is, why is this different? And where did I get the S of standard error of 5.473? So what ends up happening, if you remember from when we're doing degrees of freedom, when we did that before, what ends up happening is that you had to do it divided by n-1, because when you choose the second to last option, again, I'm using the keypad here, which I changed all my transitions to. With the degrees of freedom, when you choose the second to last choice, you're also making the last choice. So now here, notice, if I take the square root of this, I get 4.74. So we're closer, but now remember, instead of one variable, we have two. And that's what I'm kind of there. I think I actually made yep, see, there you go, two, magic. It's worth the fight to get to this point. So since you have two sets of variables, that last choice doesn't count in two of the different sets, so depending upon which way they're picked. So we're going to do the 89.89, and we're going to divide it through by 3 instead, because that's going to be degrees of freedom. So you're taking n-2 instead in this case, since we're doing with two variables. So now when we take the square root of the answer, you get your 5.474. And you can clap if you wish. So why is it different? We divide by n-2. Ooh. One degree of freedom. Do I say for each variable? Wow. It's almost like Mystery Science Theater 3000, except I'm not making jokes while I'm doing it. So again, notice again, I think I'm pointing out here that you're having one for both. I don't know what I'm saying, but I'm excited about it, I can tell. All right, so that should be wrapping things up. We're going to go ahead and move